Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
Okay, so in my last video tutorial 172, I introduced you to a project that we're currently doing, that I'm busy with, working with a friend, a colleague in New Zealand, focusing on cycling, specifically cycling in 3 locations, etc., etc. So I introduced you to that video, which used Earth Engine to generate some statistics or some data for each of those locations, that data being participation, rain, which is time series format, and then we had elevation and slope, which was single data, was a single image. So in this particular video tutorial, I'm going to continue with this project, and we're going to do some work on night lights, nighttime lights, and population, because I want to add that also to each counter. So for each counter, I want data on elevation, well, on the counter itself, the volume of cyclists that went through that counter. So I've got the Y variable basically, which is the number of people cycling. Remember, the assumption is they're going to a single location, which is the CBD. So we've got the number of people that cycle on that specific path as measured by that specific counter. So that's one thing. Second thing is that we've got distance, obviously. We've got now also rain, we have elevation, and we have slope. So we're building our explanatory variables or our control variables we're starting to build now. And so the next one I want to do is nighttime lights, because I'm going to use that as a proxy for GDP. So, and then I'm going to do population, which will be basically the number of people obviously will depend, the number of cyclists will obviously depend on the number of people staying there and vice versa. So that's what I'm going to do in this particular video tutorial, is to generate those data. Okay, and here's the script for that. Okay, so we start off again by adding our counters. If we just go and have a look at it, it's the 89, I think it's 89 counters. And there they are in the 3 cities. That is Auckland, Wellington, and Christchurch. There they sit. Okay, and then I've added 3 buffer shape files. And each shape file, I don't have my QGIS open now, but this is the Auckland buffer here. And I think that is 30 kilometers radius. So each of these buffers, which is just a circle around that, remember the CBD is my midpoint. So I use the CBD and I created a buffer. And I did that in QGIS and I saved it. And I just imported it via the asset function. Okay, so I think Auckland was a 30 kilometer radius buffer. Christchurch, I think is a smaller. I think that's is small. So that buffer is not that big. But at some point it will come up. That's a problem now. There's a lot of them, so they're going to struggle. Anyway, so let me just rather show you. Let me go. So there's the Auckland buffer. There's Wellington and Christchurch will come. But if you look at the Christchurch buffer, if we open it up, you'll see it's a circle. And then it looks like that. And I said these buffers work. You can see the Christchurch buffer is much smaller than the New Zealand, the Auckland buffer, and waiting for the Wellington buffer to load. Anyway, so there's the buffer for Wellington. Now these buffers are basically the radius are the maximum distance for the maximum distance for the most far from the distant counter. So the buffer is on the edge of the most distant counter. I hope that makes sense. So that's how I draw the buffer. So these buffers capture all of the counters within each of these cities. Okay, so those are my 3 buffers, and the buffers are basically put in to generate images. To generate images for these um, locations. Okay, so first of all, I declare that I'm working with this, not declare, I convert this into a feature collection, okay? Because within a feature collection, it has a geometry that we're looking for the lat and the long, okay? I have my dates again, start date and end date is exactly the same as the previous, nothing different to that. Exactly the same as the previous code. Um, so, and then I have my end months, we've already done that, which is similar as last one. Remember, it's exactly the same as we did here. The end months, which will be 96, and then we generate the list of the months from 1996 to January to December 2023. So that's what we've done there. So basically, we generate this column. Okay, so we generate that column from 2016, sorry, 2016 January. So that was done. Then there's our data set. There's our data set. There's our band, our start date and end date, and then we generate our coordinates, our points. So we're telling them now the Earth Engine use these counters, and for each counter generate a lat and a long. Okay, and then allocate or generate the data for those months for each of these lat and long points. And that's basically what we're doing here. Okay, so similar to what we've done, we reduce, in this case, the data by median, and we reduce the location also by median. But in this case, it's monthly data. Now, in this case, there may and it's point location, so we're not going to reduce it by median. But if it was a polygon and it was daily data, then obviously these two reducers will kick in. Okay, but in this case, we're not reducing it at all. And then remember the scale of the data set, and the band that we're getting. Okay. So that up to that is exactly the same as we did previously. We just combine, we create a list, meaning we create a data set for it, and we create a table for it, and then this is the details of the table, the nighttime lights, then the lat and the long, then the counter and the city, and we just export it to our project folder, giving this the name of it. So basically exactly the same as we did previously. Okay, nothing to it. Because there's your list of the months. Let's convert values dictionary with month keys, return the feature, apply the function to all locations, and add this to our data set. Okay, and then we export it. And this is what it, okay, so it will go into our task window, and from there we just run it. This is how it looks like. Now I just swapped it around a little bit, because remember in our data set, it will first be the nighttime lights data from 2016 to 23, then the lat and along, the counter and the city. I've just already swapped them around so that I have the lat and along, the counter and city, and then the data set. So that must again be 1996, 1996, and um, let's just go and make that. That's going to be 01 as well. So that's January. And I'm just going to go and format the cell there quickly. So that's month and year. And then we're just going to drag it straight through. That should be December 2023. 2003. Sorry, so it should be 16. 2016, sorry about that. 2016, January 2016, and then we just drag it down. Okay, that is it. So this is the nighttime light intensity. Let me just put it on a graph for that around that specific counter. Okay, so let's just put it, go back there. So that is the nighttime light intensity for this, for this period Come on, why? Hey, why is it doing this now? Yeah, so this is the nighttime light intensity for the location in and around Christchurch. Okay, for this particular counter. That is the nighttime lights. So we're going to add that value to our counter. So we're going to most probably use a median or an average value for this whole period. Okay, so let's go that way. Okay, so that's now what we've generated. So there's another set of data, a data set that we can use to add into our main data set. And so we're going to move to a data set that roughly looks something like this, where we have the counter, the city, the Latin along, and that obviously is the city center of Wellington, the distance from that counter to the city center, the elevation of that counter, meaning the height above sea level, the slope of that counter, um, the number of people that have used that counter, and that is a median for the whole period. Because remember, I'm now converting the time series into a single value. So that's the median number of cycles that go through that per month. That is the median light value, nighttime light value. You see it's monthly, it's average. And this is, yeah, that's the average rain. And now, and I've also logged it. Okay, I've also logged these variables. So this is what we've conjured up so far. We've conjured up a distance, which we did in Excel. We did elevation and slope, which is a single value. We did that in Earth Engine. The cyclical numbers is that what we derived from the counter itself. The lights is what we've just done now. That's a median value or mean value of all the values. So that's a single value for the whole period, because I can't put in time series here. So we can put time series in here. And then the rain, and then I just log them. I like to, when we do the modeling, I like to log these values. So this is so far what we've done. Okay, you see there's the counters. There should be 94 of them, or 86. There's 86 of them. Sorry, there's 86 of them. The vast majority of them is in Auckland. See, half of them is in Auckland. Yeah, there's 86 of them, each with its unique um, Latin long, and then it's a Latin long of the city, CBD, distance. So I hope you understand what we've done here. So this is now starting to look like a data set that we can use in terms of modeling the impact of these variables. Remember, this variable here is my Y variable. That's my dependent variable, the one that we want to explain. And these would be explanatory variables. Okay, so let's have a look further yeah, that's what we've just now exported. Okay. Then I declare the buffers, so here I've got the time series of nighttime lights for each counter for that stated period, 2016 to 2020, end of 2023. Okay, so that's what we've done up to this point. So what I want to do is I want to generate an image for each of these cities, not the city as entire, only that part of the city that has a counter, to visualize what nighttime light looks like, what population looks like, etc., etc. So it's not just the numbers, but we're actually now visualizing it. So that's why I've brought in the counters, the buffer zones, the buffers. So that's where I declare the two buffers. So the New Zealand buffer, the Auckland buffer, A is for Auckland, is Roy 1. The Christchurch buffer is Roy 2. And the Wellington buffer is Roy 3. So I declared it. Okay. Then there's my clip to column. Okay, so we're going to clip all of the images. We're going to clip to these rows. Okay, we're going to clip to these rows. Okay, that's basically what we're saying there. Take each of these images that we're going to generate, and we're going to clip it to the row. So here we got the nighttime light data set, and we're going to generate a 23 and a 2013 and a 2023. Um, we should actually do it 2016 because our data set starts in 2016. So there's actually no point going 2013. So we actually should do it 2016. I'm going to leave that 23rd. Okay, let's change that to 2016 as well. Okay, so there's our data set. That's our band that we use. That's our date filter, and we clip it to our region of interest. In this case, this is Roy 1, so that would be then for Auckland. Okay, there it sits. Okay, then we do it for 2023. Also the same, so there's two images. So that's going to be 2016. 2016. I'm not going to run it because it takes quite a long time for these images to load. So that would be 23rd, 20. That would be 2016 for Roy 2, which is Christchurch, and a 2023 for Christchurch. And then we do a 2016. I don't know why I did 2013. Can't remember why. And we do a 2016 for Wellington. That would be Roy 3, would be Wellington. So we create a 2016 and a 2023 image for each of these three locations, and we clip the images based on these buffer zones that we just created. Okay, we do the same population. There's also population, also 2013. So let's make that 16 as well. So the population comes from World Pop. So we do a population and then we just clip it for our regions of interest. So I use two different types of codes. I use the long one, and we can use the short one. And we would just basically declare the two images and then just adjust it in this fashion. Same thing, just two different ways. So let's just quickly change that as well. And in both cases we use the let me just quickly, in both cases, so I want to make sure, oops, 2023, don't want to make, we must be careful. So that's 2016 as well, so let's just make 2016. Sorry about that. Should have done this before the time, but then so it's all sums, so population is sum, and nighttime lights is median. In fact, I should make that sum as well. That should be sum as well. So it's just the intensity of night light, not the. What did we do in the data set? Median. We use the median as well. It should actually be the sum. That's a much better approximation to GDP than median. But let's leave it there. Let's leave it. You can play around with it. So yeah, the reducer is actually quite important here. I would prefer the sum, but let's leave it as it is. And then let's have a look and see what I still have to do. Population 16, 16, 16, 16, 16, 16, etc., etc. Okay. So in the first part, I haven't generated the time series for the population as yet. I still have to do that because I want to generate a similar time series like this. But for the population, now the population is only annual. So we're just going to generate a population number for 2020, the latest population number for each R. Yeah, so we will do that as well. But we've generated a time series for each counter on a monthly basis for this period. We've done that, okay? So then what we're doing now is we're generating an image, a 2016 image and a 2023 image. Okay, we're generating that for each of these locations based on our buffer zones. So we've created a buffer zone basically to capture all the counters. So the buffer zone, the radius of the buffer zone is the maximum distance of the furthest counter I hope that makes sense. Okay, so that is how I generated the buffer zones. And then we use the buffer zones as our ROIs, and we clip our images based on these buffer zones or ROIs. And this is basically what it looks like. So let's quickly zoom into Auckland, and let's hope it doesn't take a long. So let's quickly. Auckland is, which one is Auckland again? Auckland is ROI 1. So let's quickly take these ones out. And let's just do ROI 1. There we go. Um, there's ROI 1, nighttime lights, ROI 1 population. And Auckland, so you see if I take, okay, so I will show you now, if I take this out, there we go. So you see, so that's the buffer there, sits there. And then obviously, yeah. So, okay, so let's quickly go for it. So the white is the counters. Okay, so I brought that in, that's the counters. So the white is the X amount of counters that's within Auckland. Let's make it zoom a little bit in. So this is, let's just quickly wait there. It does take, unfortunately, a bit of time. So let's take the buffer out because it just muddied the water. It just puts a layer over that, which is unnecessary. Okay, so that is the counters. You can see the counters. The majority of the counters are located around the CBD. Okay, the majority of counters is around the CBD, and that's also why we've decided to use this as our destination point. Not the point of origin, but our destination point. So that is in 2023. That's 2013, and that is 2023. That's 2013 and 2023. Okay, so if I zoom in, if we zoom in, let me just quickly take this one out. So you'll see that some of these counters will have the same nighttime light intensity because they're all in the same. So for example, these two, let's say that these two, this one will be, these two will have the same nighttime light number because they're in the same um, pixel, the same nighttime light pixel. Okay, so they would have the same value. So these two will have the same values. They will have that will have a unique value, a unique value, a unique value, unique value, unique value. This one will have a unique value. This one will be unique. So there's some of them, the majority of them will have unique values. Now that's going to be an interesting one. It depends on how much it overflows this side or that side. Earth Engine will determine the value that it allocates to that. So yeah, so that's just, but most of these will be, yeah, as I said, you can, yeah, so that is, so it calculates then. So let's have a look at the population. So there is our population images. So let's put it like, okay, so I'm not going to put it. So that's the population. Population is world pop. So let's just drill in. You can see the population is much higher resolution than the nighttime lights. Let's just quickly show you. Um, so uh, there's the nighttime lights and there's the population. You can see it's much smaller, or much higher resolution in the population. Now you can see here. Uh, in most cases, they will have unique numbers. You see that one and that one. The resolution is so high that they all will have basically unique numbers. Different. That's 2016 or 2013 in our case. Before I haven't rerun it for 2016. That's 2013 and that's 2016. That's 2013 and 2016. Not much difference per se. Okay. I hope you get the idea. So that's the, from a wide angle, that's the GDP, or the, let me put it this way, that's the nighttime light image or nighttime light profile for this for the Auckland area for 2013. And that's a nighttime light image or profile for Auckland in 2023. You'll see that there's the highest, the furthest distant counter, and that's the distance of, that's the radius of the um, buffer zone. Just for interest, let's just show you that. So that is the nighttime light image for 2023, which is, I think we put it as a median. And this is the population in 2013. And this is the population in 2023. Sorry, in 2022, population doesn't, world pop doesn't go to 2023 population. So but world pop actually goes only to 2020. So I just multiplied it by a population growth rate and went to 2022. We should actually use Landsat. Problem with Landsat or Landscan, sorry, not Landsat. Landsat is data. We should actually use Landscan, but the problem with Landscan, its resolution is just too high. So you'll have most of these locations within 1 pixel, 1 or 2 pixels. So most of them will have exactly the same value, which is counter what we want to do. Each counter should have unique values. That's our point of it. We need to generate unique values for each counter. And therefore, if we use Landscan, and I did, then it doesn't work because all of these will have roughly the same value. That's pointless. So that's why I started to use World Pop because of its resolution. Problem with World Pop is that it only basically goes to 2020. And therefore, I just did a bit of manipulation of the data sets to 2022. Could have done it to 2023. It's just a straight line growth model that I applied to those images. And I did that into QGIS using the calculator. I presume you can do it here as well. I just found it to work easier. So that is just the images for Auckland. And we did the same for Wellington. So let's check that out. Now Wellington is, I think, 3. Yes. So that's a nighttime light for Wellington, 2013. That's a nighttime light profile for Wellington in 2023. That's 13, 2023. 13, 2023. And that's the population in 2013. And that's the population in 2022. It's going to happen now. So that's 2013. And that's 2022, nothing much happening different there. And we generated the same for Christchurch. Let's take that away. So that would be nighttime lights, nighttime light intensity or medium for Christchurch in 2023. And that's for 2023, 2013, and that's now 2023. Why is these numbers confusing me now, these dates? So that's 2013. That is 2023, 2013, 2023. And that is the population distribution in 2013. And that is the population distribution in 2016. Okay, so I hope you get the idea of what we're doing here. Let me just activate them all before I conclude. So what I need to, so we generated images now for each of these locations or each of these cities that captures all of the counters. And we generated a nighttime light and a population image or profile for each of these locations for 2013 and 2023. And we've generated also a nighttime light data set in time series format for each of these locations from 2016 to 2023. I just need to do a population one. And I just need to do a population one, which I'm going to do right after this video. Okay, so again, using Google Earth Engine in a very practical sense, generating information for each of these counters that hopefully we can use in explaining patterns, cycling patterns, use of these, what determines them, influences, etc., etc. So if they decide to do these in other towns and cities, they'll have a model to determine whether it's going to be financially viable, etc. So by usage and all of these sort of things. Anyway, okay, so that is also a nice piece of code, also working some good stuff in here, and hopefully it makes still sense to you. As I said, at the moment we're just generating data for each cycle, for each counter, and what you want is you want unique values for each counter. So you need to get data sets that has a resolution high enough to generate unique values for each counter. It doesn't help having most of your counters having the same values. Then it's not really a unique value. It's not going to add to your model. So just throw it away. Just don't care. So that's a nice thing with high resolution images, is that you can do these sort of things. Now, if the counters were more spread out, there was bigger distances between counter, then obviously you can use lower and lower resolution images. But in this case, given that our counters are so close, so clustered, we have to use very high resolution data sets. Okay, so I hope that makes sense. Take that into account when you do this sort of work. Okay, and there's a script to generate the data, and as I said, I'm going to quickly generate the script to do develop the script to generate the population, but only for 2023. And I'm just going to basically assume that's a for 2023. And I'm going to add it. So we're going to then have within this data set, we're also going to have then a variable called population, pop. We're going to population. I'm just going to population. We're going to also have a variable called population, and then obviously a log of that as well. That gives us now, there's our dependent variable, and so far we've got 1, 2, 3, 4, 5, 6. We'll have then 6 explanatory variables. Now, there's certain things that unfortunately, because we have to have unique values for this, there's certain things that we can't put in. So, like oil price, for example. I would love to put the oil price in here to see the cost, determine whether, there's a cost benefit of going cycling, etc. But anyway, there's certain variables that's going to be quite difficult because it's not a unique value. The oil price is for all of them, and therefore we'll have to do that in a time series model. So this is a spatial model. So that's why we need unique spatial values. When it's time series, you need a unique value for time. So we're going to do spatial modeling on the one hand, and we're going to do time series modeling on the second end. The time series modeling, we're going to work on time series data. Here we work on spatial data. So there's a slight difference between, and then hopefully we're going to marry these two. Okay, so I'll take you through some of the modeling that we're going to do. I'm not going to do the modeling within Earth Engine. That I'm not going to do. I'm going to do the modeling in QGIS and in R and in eViews. But I'll take you along for that journey as well. So I'll take you along on the journey of doing this research, because the idea is we want to generate some primary knowledge information that we're going to publish in accredited journals. And so this is part of that process. Okay. So I hope you understand where we're going to go to. We don't have clarity on exactly what we're going to do. We're just generating data. We're just, fishing like crazy to see what we're going to quote. And then hopefully the data will sort of guide us or help us, assist us to formulate hypotheses, etc., etc. That then we're going to formally test. Okay, so I hope that makes sense. So with that said, let's end the video for now. And I will, and thank you very much. Yeah, thank you very much for your support. Let's get that 1,000. Let's get that 1,000. By the way, that's another milestone. Huh? This will be my 200th video. We started the channel in beginning December last year. I have the oldest one. Let's have a look and see what the oldest one is. 8 months ago. 8 months ago, I did my first one. So we did 200 videos in 8 months. Now, whether it's good or bad, I have no idea. I don't know. I presume there's people that's doing more than that. There's people doing less than that. It's not necessarily about the number of videos. It's about this magic number. But I'm confident that the more videos, the higher subscribers. So they seem running, very similar over time. So yes, another milestone. We reached the 500 over the weekend, and now we've reached the 200 videos milestone. So I'm very chuffed with that. So thank you for all your support. It really means a lot. Your comments, the numbers, everything just makes you want to continue with this. So remember, we're exploring, we're going where nobody went, not nobody, where we haven't, or I haven't gone before. So we're going really in the unknown. We're generating information, we're generating knowledge, and that ultimately is what the channel is all about, is using remote sensing to do these sort of things. So I hope you enjoy it, and thank you for your support, and then I'll see you on the other side.